Our next speaker is going to be Michael Meyer. He's going to talk about the future of U.S. Mars exploration. And Michael is, you're going to introduce him? Go to.
Hello, everyone. Michael Meyer, as Robert said, is our next speaker. He is a senior scientist at NASA's Science Mission Directorate in Washington, D.C. He oversees the Mars program's science operations and planning and also serves as program scientist for the Mars Science Laboratory Curiosity mission, which you know, 7 years ago this month, landed up, was it 7? 6? This, I can't add. It's the anniversary. Previously he was the scientist for astrobiology for the 2001 Mars Odyssey mission, and he also works on planetary protection, which I'm sure will come up at some point. Dr. Meyer.
I'm a little nervous about following Bob in a talk. It occurred to me, just 2 years after the publication of End of Science, it was just 2 years before that we confirmed the first planet around another star, and also ALH 84001 purporting evidence of life on Mars. Anyways, I thought that was... Well, something may show up. So what I want to do is kind of basically, I'll talk to what I know, and so I'll tell you about the Mars program, where we are, what our intentions are, some of the things that we've discovered recently, and then be here for questions. So how's the Mars program doing? All our missions right now are doing very well. I would say the only one that's up in the air is Opportunity, because we haven't heard from it since May. But things are looking a little bit better. I'll talk a little bit about its circumstances and the status of the global dust storm that's going on Mars. We are progressing very well in what we're developing in terms of future missions. 2020 has gone through a milestone, in that basically the hardware is now being cut for the mission itself, and also a helicopter has been added as a technology demonstration. The MoMA, the instrument that will go on ExoMars, also in 2020, is capable of measuring organics. It also has a laser desorption mass spectrometer, so it could measure heavy organics, very refractory materials, and I think that would be a really interesting thing, what that mission will find out. MAVEN, Bruce Jokoski, who's the PI of that mission, who we've heard about already. That mission has been very successful in measuring the solar-wind interaction with the Mars atmosphere and getting measurements on how much loss there is from the solar wind blowing Mars atmosphere away. And this year we'll be moving into a lower orbit to basically facilitate communications, and yet still be able to do about 80% of the science that it's doing right now. We are progressing very well on technologies that we need for Mars sample return, and one of the things that has happened this last year is getting ready for the next decadal survey for the planetary sciences. So essentially that will be kicked off in the beginning of January, and basically almost a 2-year process to map out what we want to do in the following decade. And they just released a midterm report a couple of weeks ago. So one of the things that happened in this year is very good news for our budget, in that the Mars budget has gone up, which is, it's been going through some tough times for the last 5-6 years. And what that does is it helps us keep the missions going that we have going, and also affords us the money to progress in development of the missions that we hope to do in the future, such as 2020, and also start planning for a Mars sample return. And so we're busy putting that together so that hopefully it will be in the next budget cycle. Other things that are going on, InSight is launched. This is a discovery mission, so it's not officially part of the Mars program, but certainly is something that every Martian is looking forward to in measuring the geodesy of Mars. It's a little bit over halfway there now and lands the day after Thanksgiving in case you wake up from all your turkey and want something to do. Also, we're doing sort of an experiment with 2 CubeSats that are going along, and what they're going to do is provide communications for the entry, descent, and landing of InSight itself. So that'll be interesting to see how well that works. Trace Gas Orbiter is in its science orbit now, so we're looking very much forward to the measurements that it's going to make. It also has the advantage of carrying Electra, so we have some backup for communications in case our aging assets don't make it through 2020. And then also we're teaming up with JAXA and providing an instrument and some technology for sampling, and that should be very interesting going to the moons of Mars. So what's been going on? So one of the things that you might be aware of is the Curiosity, the 1-ton rover on Mars that landed in 2012. The drill feed mechanism was not working, and so we went through a hiatus of over a year of not being able to drill. So they've come up with a different way of doing it. They've moved the drill feed out of the way, and so basically now, it's a couple months ago, they finally drilled using a new method on a rock called Duluth, and that's been very exciting. And things that are moving ahead, I'll talk a little bit more about some complex organics that have been found on Mars. And then that small picture in the bottom, let's see, does the arrow show up? Okay, I think I'm circling and I can't actually see it. That's a difference in the lighting because of the global dust storm, looking at the same rock. And as you can see, later into the dust storm, you're getting a preference for longer wavelengths. It's kind of interesting. So, and just recently, we finally drilled another rock, a second drilling with the new technique. We had a bit of a problem. This is the 3rd try, and what we've discovered is the rocks on Very Rubin Ridge, which is where the rover is now, are harder than the rocks we tried to drill in the past. And it wasn't until our 3rd try of finding a slightly softer rock that we were able to do a sample. And analysis on that sample is going on right now. So let me talk a little bit about some of the more important results that have happened recently. One is, as you might remember, when Curiosity landed within the first year, it drilled a sample in Cumberland, this is in Yellowknife Bay, and found organics. They were chlorinated compounds, and this is very exciting to find them, and also it helps fuel and perhaps solve the mystery of chlorinated compounds that actually Viking found. And what it does is it points to the idea that, yeah, there are organic compounds on Mars, but there's still a debate about how much is left. It's still lower than what we would expect just from meteoritic infall. And a big debate about what's happening to them and what process is scavenging the organics that we see. Well, it turns out that on another sample called Mojave, this is at the base of Mount Sharp, it's still part of sort of what we consider sort of the lake complex that surrounds Mount Sharp in the base of Gale Crater. And we drilled there, and lo and behold, with a lot of work, we've been able to sort out that at the higher temperatures beyond the realm where perchlorate operates, so one of the things that we strongly suspect has happened to the organics on Mars, at least for our being able to measure them, is that as you heat the sample, perchlorate that's in the soil basically combines with any organics and cooks them, and it comes off as CO2 at basically lower temperatures between 200 and 400 degrees centigrade. Well, after a lot of lab work, the idea was, well, there may still be some very refractory compounds that perchlorate doesn't affect, and maybe we can find them. And so they did some work and found at higher temperatures you can get some organics coming off. And they found that there are some sulfur organics that are combined with sulfur. And it turns out the sulfur is helping preserve the heavier weight organics, similar to, it's called vulcanization, similar to what we do with rubber on our tires. And so this is actually very promising in telling us that there are larger molecular weight compounds on Mars, something to be looking for. And then if we find the place where they have not been irradiated by galactic cosmic rays or UV radiation, that there may be enough organics there to be preserved and for us to be able to identify them and be able to tell what their source is. So here's just a cool picture of a hero shot of Curiosity, but showing you the ring compounds that have been found at coming off at higher temperatures from the SAM analyses. So out of that, we have reconvinced ourselves that we are looking at organic matter in ancient lake beds. This is organic matter that has been around for over 3.5 billion years and is able to survive in one form, lots of radiation. Galactic cosmic rays will penetrate meters of regolith. And the point is, if you can have something survive 3.5 billion years, if you can find something that hasn't been exposed close to the surface until recently, that you should be able to find many more organic compounds that will actually give you a better sense of their origin. It actually expands the period of time that we think that Mars has been habitable, and it certainly adds to our quiver in terms of number or types of strategies that we might use to discover evidence of life on Mars if there ever was. Okay, let's move on to the global dust storm, also known as a PEED, Planet Encircling Dust Event. So near the end of May, it was a local dust storm was spotted in the northern hemisphere, and as it was observed, it was moved down the Acidalia chain. Basically, that's kind of near that gore that is showing up. I can't see where the arrow is. Showing up basically to the left of the M of MERB, which is opportunity. And that moved down the corridor, moving south, and then by January, and we warned Opportunity, hey, there's a dust storm, local dust storm coming, you better hunker down because, as you know, Opportunity is solar powered, and when you turn off the lights, it doesn't work very well. So, but as it moved south, it stalled a little bit in the Meridiani area, and then combined with local dust storms in the south, and we got a planet encircling dust event. So we've had a global dust storm. Before the last communication we had with Opportunity, they were able to measure a tau, basically atmosphere opacity, over 10.5, which is pretty impressive. But we have not heard from Opportunity since then. Here's what you would think. This is what you would see from Opportunity as you increase the tau. Tau around 1 is sort of typical on more dusty seasons during Mars. In the bottom left, you see a graph that has power to the solar panels on Opportunity in red, and what the atmosphere tau, measurement of tau is in blue. And as you can see, as the dust storm arrives, precipitous drop in the amount of solar power and also the corresponding rise in tau. Even Curiosity sees the dust and has measured increases in tau. I think it's gone a little bit over 5 that's been measured. And now it's actually dropped down, we think, around a little bit less than 2. And this has been measured from orbit and kind of estimating what the tau really is. But this gives you an idea of that the dust storm really is has a major effect on the lighting in the area. As Bob mentioned, one of the big discoveries is a subsurface lake in the South Polar layer deposits. That triangle-looking thing is, in fact, the radar reflection from Marsus that points to what they consider to be a subglacial lake. There's a couple important things about this. Is A, it's going to be difficult to confirm that this is true just because you're looking at through 1.5 kilometers of ice. But the other is just from your kind of calculations of the environment, is that the temperature of that water is probably around 205 or so Kelvin. Can't actually measure it directly right now. And that points to, if it is liquid, that it's going to be extremely salty. So it's not something that Earth microbes would be able to take advantage of unless you desalinated it. Earth people could take advantage of it by desalinating it. As I mentioned, InSight is on its way to Mars. It launched in May from Vandenberg, and it's well on its way, and looking forward to that. All the instruments have checked out. They've gone through their first checkout in cruise phase. That's great news. Then also, Mars 2020, as I mentioned, has been just went through its KDPD, and so that's the last major decision point other than are we going to launch it or not. And this highlights the international involvement that we have on Mars 2020. One of the things instead of going through all the instruments, you can kind of look at those yourself. What I want to do is point out what's different that compared to Curiosity. It uses the same chassis, but there's some fundamental differences. One is we changed the wheels. We thought that might be a good idea, and so they're more robust than the ones we have on Curiosity. It has a subsurface radar provided by the Norwegians, and I think that's going to be very interesting to be able to look in the upper couple of meters as the rover roves around. But its major feature is it got rid of the analytical lab in the interior and has put in sample caching capability. So this rover is going to go around. It has the ability to identify organics in samples, also remotely because of its SuperCam, and cache samples for a future mission to bring back. So that's going to be the major activity. It has some Raman UV, so it could spot organics. It has a micro X-ray imager so that it can give you elemental composition and distribution on a microscopic scale. And so these are the kind of things that you should be looking for when you're looking to find samples that might have evidence of life. The other thing that you might be interested in is that it also has a contribution from the Human Exploration Program, and that's MOXIE, and this is a in situ resource utilization instrument that will take CO2 out of the atmosphere, will take CO2 from the atmosphere and make oxygen. And its goal is to do that on a regular basis and get oxygen pure enough that then it could be used as the oxygen for future rockets or even for habitats. So we have the Mars program. We're doing very well. One of the things I want to point out looking at this is it's starting to get crowded, particularly in the 2020 timeframe. We have other countries sending missions to Mars. And in fact, the Chinese have said that they're going to go to Mars and return samples in a similar time frame that we're sending Mars 2020, and hopefully in the future, if things pan out, that we'll also be able to get those samples and bring them home. So 2020 ends up being, it could be a real challenge just for our communications, just because of the number of spacecraft that are going to be there and who will want to send their data home. So that'll be fun. So one of the things that was in this year's budget was to study doing sample returns. So we were busy in going through the architecture. In fact, in a couple of weeks, we're going to go through sort of our mid-architecture review to see whether or not we have the right concepts for how to get the samples left by 2020 and bring them home. And that's going very well. why sample return now? I mean, it's one of these things where it's been the goal of the program for decades, but why now? Well, we have the infrastructure there. We have orbiters there. We have the capabilities of sending. We don't have to send an orbiter and a lander. We already have the orbiters there. We are scientifically ready. In fact, in mid-October, we're going to have the last landing site workshop for the science community to pick the landing site that we're going to send 2020. The debate is not whether or not we can find a safe place to land. It's quite the contrary. The debate is which place shows the best opportunities for the science. So we know where we want to go, and now the hard part is picking between some very good options. Our science is evolved to the point that what we really want to know about samples from Mars is at the microscopic level. We need to bring those samples home to look at them, and then you have the huge advantage of the latest instruments. You're able to manipulate the samples, and also when you get surprised, you can use a different instrument that you never thought you would be using to follow up on your discoveries. And our technology is there. We think we've already had rocket tests for the Mars Descent Vehicle. We've gone through a lot of testing of how to isolate samples and bring them home. So I think we're ready. Technologically, it's not going to break the bank. And science-wise, we've been waiting for this for quite a bit. So with sample return, we're going to be a very focused, no bells and whistles kind of sample return. But we're not compromising the science of the samples that we bring back. We're going to bring back a lot of samples, well chosen by 2020. What's going to be focused on is just doing that, not adding other things to the mission, not driving up the cost. We've been working very hard on partnerships. We have things going. We have just recently, this April, we had an International Mars Conference on Sample Return. It went extremely well. At that meeting in the Berlin, at the same time as the Berlin Air Show, we had the head of ESA and the head of NASA sign science mission director, sign a document saying we're going to collaborate on planning on doing sample return. And the great thing about that letter of intent is that it actually maps out the different responsibilities of who's going to study what and what they're going to come forward with. The sample containment is going very well on 2020. That was a big engineering challenge, but it looks like that's going to work well in isolating the samples from the world that we live in, so they come back and what we find will be Martian as opposed to Terran. As I mentioned, we have more communications in TGO, so we feel fairly robust. And the National Academy of Sciences just put out 2 reports in the last, I guess, month and a half. One is what we should be doing in our decadal survey coming up and how we've been doing so far, in which they re-emphasize there should be a Mars program and that we should be doing sample return. And then also a big challenge that we had over the last several years is planetary protection. So the Academy also did a report on what they think ought to be done for planetary protection and how to move forward on that. So that's all very good. So we have a healthy program. Our missions have been very successful, and I appreciate Bob even complimenting them, saying luckily they know what they want to do, and so it's just about doing it. And we are working on a lower cost way to do Mars sample return, and so I think we're going to be able to do that, and we have a good partnership going, and we're preparing the science community for our decadal survey that will be coming up over the next couple of years. And with that, I think the next slide, and I'm ready for questions if anybody has any. Thank you. Okay, there's 2 questions. Okay. Oh, you control it.
Thank you for that. Will there be a microphone on Mars 2020, and when will it be activated, if there is one, and what would you expect?
So the answer is we plan on having a microphone on 2020. I actually think it's part of the SuperCam. They have figured out by having a microphone, they can get a better idea of the amount of energy that is going into their laser shots. and that actually helps them calibrate what they see in terms of elemental composition, because the strength of the signal gives you a better idea of what energy should be coming off. So the answer is we'll turn it on when we get there. And the only reason I hesitate is I'm not positive it's still on. I think it is, because I haven't heard anything about it being taken off. But that was kind of an add-on after they already got selected. So it's not a critical component of the laser desorption system, but it's I think it will help a lot in terms of understanding the data that we're going to get back. Good question. Yeah.
Sir, I just was wondering, I read about possibility of doing something where you could send a craft low down and pick up dust, like AKA like a Genesis type thing. Is that worth doing? Would you get enough science out of it?
Yeah, so there
and it's kind of low cost.
A proposal a while ago. Oh, SKIM was the name of it. Yeah, and Lori Leshin was the PI. That didn't get selected for the mission itself, although it did very well, and I think it got a Category 1 rating. And there's a corporation called I think it's called Tubodali Gold, and they are hoping to do a form of SKIM with private dollars. And so we've been talking to them, and NASA will provide help with communications and navigation, that sort of thing. And I'm just not sure where they are in terms of how well they're doing raising money to actually have the mission accomplished.
Okay, last question.
Can you give us any updates on what steps specifically will be taken over the next decade to increase communication bandwidth between Mars and Earth, other than just send more orbiters?
Yeah, I'm trying to think. There's I don't know enough about it, but there are ways to increase the bandwidth using the similar technologies that we have now. But I'm just blanking on a better description of it. We don't currently have plans for an orbiter to Mars. The Europeans may be sending to Mars as part of sample return, and whether or not they want to include something that will stay in orbit when the samples come back, that's kind of up to them to figure that out. We put out an RFP, request for proposals, several years ago, the idea of asking the commercial world, hey, do you guys want to send missions to Mars, and we'll buy data. And the proposals that we got back were reasonable and credible, but we haven't done anything more than that to move that forward. I think this is something that's going to come to a head in the next couple of years, because our assets anyway are aging, and pretty soon we'll be looking at a real dearth of communication capability when Odyssey and Mars Reconnaissance Orbiter bite the dust. Yeah. Thank you.